And welcome to Hadoop Exam Learning Resources. In this training, we are going to start with the Spark SQL. So this is the new training on SQL interface of Spark. Okay, so there is not only SQL query you can write it, even you can write a procedural language using the Spark SQL. So let's go into this training. Fundamental concepts we will cover right now, and a lot of hands-on exercises are coming up in the future session. So let's cover first fundamentals, and we will slowly move towards the hands-on exercises. Okay, so in this session I'll cover this topic. So what is the new in Spark SQL, how it differ from the other SQL engines, and what are the main goals of the Spark SQL. This is DataFrame API, Dataset API, and basic concepts of data pipeline and user data functions we will cover in this. Okay, so this is fundamentals and conceptual sessions. Okay, not hands-on exercises we will be covering in this session. In future session we will have a lot of exercises coming in. So let's start with this. So what is the Spark SQL actually? So Spark SQL is, as your name suggests, is a structural query language. Support is provided in the Spark SQL. Not only this SQL queries, but there is a API as well available, like other programming languages. You remember Java, Python, Scala. You write programs and you can do the data manipulation and etc. Correct. So similarly in Spark, even more advanced version of the predefined API for the dataset activities, and like this is little confusing nomenclature here, that is you must be aware about this. So by the time we finish all the session you would get to know more in detail. Okay, so dataset API and DataFrame API as Spark SQL 2.0 onwards, it is the same thing. Okay, the only difference is dataset API is only available in Scala and Java. If you would be working in Python, then this API is known as a DataFrame API. So in Python there is no data set API. Okay, remember. So but functionality in dataset API in Scala and Java is the same as DataFrame API in Python. Okay, so functionality wise both are same. The only difference is in the Scala and Java this dataset API is available, but in Python DataFrame API it is known as. So there is a little confusing nomenclature. Even in Scala Java DataFrame exists. Okay, so I'll tell you as we move ahead. Okay, so what exactly, so if you remember, Spark SQL is not very new. It was since Spark 1.6 was launched. Okay, so when Spark 1.6 was launched, since then Spark SQL is there. Okay, and before that there was also Spark SQL. I'll tell you little later. Okay, so but that time there was an API known as DataFrame API. Okay, and this API was exist in Scala as well as in Python both. Okay, now in Spark 2. Onwards, okay, so this API in Scala and Java would be known as Dataset API. Okay, and in Python it is still a DataFrame API because there is no Dataset API is available in Python. There are some reasons why Dataset API is not there, but functionality wise both are same. Okay, so don't get confused. So Spark 2.0 onwards, if you are working it, so assume it you are working with the Dataset API. There is nothing like as such DataFrame API. Okay, that is you have to remember. There is a, you would see lot of names or data. It's a construct still available in the Spark SQL 2.0 onwards, but slowly Spark is also moving towards the dataset API. So at the finally in future you won't see any data frame as such, but yes, Python would always be a data frame, known as a data frame, but the functionality is same as a dataset API. Okay, so that is what first thing. Okay, and now using Spark SQL you can have a procedural language API as well as SQL query. So if you already have attended our core Spark training in previous module, so you have learned lot of RDD API as well as a data frame API, dataset API, etc. You have learned it, correct? So this is the API Okay, so that is what the Spark SQL. So Spark SQL is a combination of, is equal to SQL query language you can do as well as API code you can write it. So if you see any other programming language, either you can write like in Java, you can write only procedural languages, correct? Oops, kind of thing. Oops, concepts are there, but you can just write a procedure, not SQL query you would be writing directly in the Java code, correct? Obviously you can use JDBC and then you use the SQL query and etc in the Java code, but that is not directly supported inside this. You have to use JDBC driver. But in the Spark SQL, with the API and with the SQL, both you can write in the same program using the same API. Okay, you don't have to import something separately or something. So as soon as we will move ahead, you will get better understanding exactly what I mean it. But just as of now, just remember this is SQL plus API. Both things are available in Spark SQL. Okay, now move to older version of Spark SQL that I was mentioning, correct? So in the before Spark SQL, Spark 1.6, there was a Spark SQL, and that was known as a Shark. It's not very important to like go in depth, but the only things you just remember is like Shark was having support only for Hive. If you have worked on the Hadoop framework, so you might be knowing what is Hive, and you must know, actually you are learning Spark, so you must know the Hive as well. Okay, because in the big data world, Hive is very important. Okay, so Spark SQL module initially is launched known as a Shark, and it was only supporting Hive. So data stored in the Hadoop framework and tables created on the in the Hive on the data, that would be only supported. So there is no other way to support the SQL queries and etc. So that was the limitation with the Shark. That's the reason they have dropped this project. Spark dropped this project, okay, and created altogether new project, and since 1.6 that is known as a Spark Spark SQL. Okay, this project, even before that I believe it was launched in 1.4, exact version I don't remember, but there's no point of remembering now. Shark you can forget about it. It was very limited to Hive. That's the reason they have to create a new Spark SQL module that is known as so now currently we are talking about Spark 2.x version and later. So 2.3 would be, we would be using that. This is latest available as of now. However, the concept of the Spark even remains same. Most of the concepts, only new features we would be adding it. So Spark SQL is drastically changed in the Spark 2.x version, so that is very important. The core API still remains same. So our Spark, if you go our previous course Spark core Spark, so that is nothing at such change, like the concepts remain same. So this training we don't have to change too much on that training. That would, the entire fundamentals on our core training would remain same, because Spark has not changed too much on that. Wherever we change, we will try to update the module, but in our core module that's fine. Okay, so let's move on. So it is limited. So newer version of Spark, what was the goal of the Spark actually? So in newer version, you should be able to like run SQL query. Not only, oh sorry, I cannot write here. Okay, not only like data stored in Hive. It should support in Hive as well as external files. If you have JSON files, CSV files, tab separated file, comma separated file, etc., that should, on that file also you should be able to run the SQL query. Okay, and if you have already loaded your data from somewhere, like from streaming data or from some file data or some JDBC data, you have already loaded in memory of Spark and you want to run the SQL query on that, then that should also be supported. So any kind of data, they like any kind, I mean structure. Okay, it's more of a structured data, not unstructured, structured or semi structured data. Okay, so your JSON is a semi structured data, so this kind of data should be supported and you should able to run SQL query as well as a API you should be able to run. That is the one goal of their creating the Spark SQL. Next, the performance improvement. Obviously Spark is the Main reason of the Spark people adopted is that it's a speed, it's a performance, it is lightning fast, they mention it. Okay, so what it's every scenario varies exactly. So so like the speed and performance varies what in which scenario you are using it, correct? So now, but still it is faster than any other available big data solution. Okay, so most of the companies who are having big data storage like NoSQL storage like Cassandra, or you would say HBase, or I would say this your HDFS file system, etc. Everybody using started using computation engine as a Spark and storage engine as their own storage engine. Okay, so the reason is the Spark is the speed it is being developed is very fast, plus it is really providing the performance what is people are expecting and needed for them. So that's the reason some one of the main goal of the Spark SQL. If new data format needs to be added, then it should not be difficult. The problem here is like day by day new data format is created. If you are coming from the Hadoop background, then you might be knowing like Hadoop itself has lot of framework like sequence file, like Parquet file, Avro file, correct? This kind of different file formats are there. So and they are being developed for better optimize storage optimization as well as a performance optimization while reading columnar database and kind of things of various storage. So what Spark SQL wants, it's like whenever a new format comes in and needs to be support needs to be added for this new format, it should not be difficult. So there should be some generalized API available so that easily the new framework can be adopted and can be supported kind of thing. So similarly right now if you see JSON and CSV and JDBC, and easily it's like as we will do a hands-on session in the future session, you will see like how easy to provide the support for this kind of things. Okay, so high, and the next goal is the high performance with other library as well. Now if you see Spark SQL has created some API, correct? That is DataFrame API or Dataset API, correct? And the same API is extended and being used in a other library of the Spark framework. This is graph library if you are working in, if you are streaming data, if you are working in, so entire streaming solution they are trying to rewrite. Okay, that is using the Spark structured streaming, they are saying it. Similarly for the graph, there was a module called GraphX in the Spark library, correct? But Spark is working on, Spark community is working on to create a more performant and easier API to be used by the developer. So they are creating GraphFrame API for the graph, Spark sorry, for streaming real-time data processing, they are creating structured streaming, and machine learning libraries also getting developed so that they can use this the new concepts created in the Spark SQL dataset and DataFrame API. Okay, so these are the main goals they have initially kept in mind. There are many other goals, smalls could be there, but these are the major goals they kept in mind to develop the Spark SQL. Now let's go a very detailed overview block diagram of the Spark SQL. So if you know this core Spark, RDD is the main concept on this the Spark work, and still if you are using even Spark SQL, machine learning, structured streaming, graph frames, anything you use it, finally your data frame or data set or whatever construct you are creating in the Spark needs to be converted into RDD. Okay, and this is the responsibility is taken by the Spark itself. You don't have to convert it, and then entire computation happens using the RDD. So if you don't know RDD, I would suggest go our core training module about the Spark core modules we have. So that where we have in depth we have covered this thing. So slowly even Spark wants you not to use directly RDD until and unless is there is a mandatory or need or some support is not available for your work to be done. Spark wants you to use dataset and DataFrame API or SQL queries. So it is developer friendly, and RDD is a little I would say complicated for the programmer. If you are a hardcore programmer, then it won't be difficult for you. But if you are kind of what I would say not in depth coding you want it, and you are not too much interested in writing very optimal code and kind of thing, so this optimization you want to leave on the Spark framework itself, then you should start using dataset DataFrame. Even Spark wants you to use, there are reasons why Spark want you to use, because Spark had developed one layer below this that is known as Catalyst Optimizer. Okay, so the entire optimization happens using this Catalyst Optimizer. If you directly use RDD, then this optimization would not be available to you. But if you are using Dataset API, if you are using DataFrame API, SQL queries, then this Catalyst Optimizer would help you. The code what you have written would be optimized by the Spark itself, and you don't have to worry about the optimization part. So that's the reason. And writing the code in dataset and DataFrame API is quite simple compared to writing using the RDD. Okay, so when you do the hands-on, then you will get to know like how simple it is. And if you are coming from the SQL background, then it is much easier for you. So if you are already working Python as a data analyst or data scientist in the Python world, then you would find DataFrame is very comfortable for you. Even Dataset API is very comfortable for you. So Spark SQL module is combination of this Catalyst Optimizer plus DataFrame API plus SQL queries you can run on it. Okay, then you can connect using command line, you can write Spark job, you can connect using JDBC to JDBC is more for the purpose like people want to integrate a Spark SQL with their other programming language kind of thing. If you want to what I would say like Java, Python and Scala already Spark is supporting. So some other languages or like JDBC is there, means JDBC is for Java only. If you want to use somewhere else, then you have to use the JDBC driver in the Java programming. If you are using some any other programming, then ODBC driver is also available. You can use that one. Okay, so that is what the purpose here. Now dataset API program means you can debug dataset and DataFrame. Right now, don't confuse between dataset and DataFrame as a separate API. It's the same API. Okay, in the Python world, it is a DataFrame API. There is no dataset API. The reason we will see in the future session more on this, you would get to know little bit. Even initially I was confused what is that, too much things to understand, and it was confusing actually. So but now dataset API program means you can debug intermediate result as well with the standard tools. What it means here is like if you know the programming, so we do the debugging correct using the, if you are using Eclipse, if you are using NetBeans, if you are using some IntelliJ, these are the tools, development tools correct, and you do the debugging of your program, what intermediate result you want to see. So if you are using dataset API and DataFrame API using this tools, then it would be easier for you to debug if with this API. Okay, so as soon as you define data set or data frame API, its logical plan would be created eagerly. What it means here, logical plan, in the next session when we will cover catalyst optimization in detail, where we will discuss about this what exactly the logical plan and physical plan and etc. Okay, so we'll discuss in depth in the next session, but let's assume right now logical plans means data types of data and its column name needs to be known, will be known immediately as soon as you define it, so without even execution of your code. So if you remember when you have writing the code in the Java in Eclipse or IntelliJ some code, so automatically give you the suggestion like this syntax is wrong, Okay, something kind of thing, correct? So similarly, if you write the code using this dataset API, you in the any supported and development environment, then it would find it out like this, the data type and column name whatever you are defining is really available in the underlying file or not. It would immediately check, and if it is not available, then it would give you the error. So that is known as a compile time safety. So rather than waiting to run your program in runtime and you get to know, oh, I given wrong column name or wrong data type, it would immediately while developing will give you this hint like the column name you are giving is not available under in the underlying file, or the column type you have defined is an integer but it is actually not an integer value, it is a string value. So this kind of compile time information you will get to know. So that is known as a compile time safety. So that is not directly available with the RDD when you work with the RDD, but when you work with the dataset API, then this feature is available. So that's the reason it is suggested you start programming using the dataset API. Until and unless it is not possible with the dataset API, then only you go for the RDD API. Okay, as data types and column check done immediately. Okay, so it's very simple pipeline when you create when you work with any what I say data world. Okay, so you would be generally creating the pipeline of your data in there are various ways. People use ETL tools to do these things, or they write their own custom programs to do this. Like first module will do these things, the next module do these things, third module do this thing, and they create the entire pipeline, transform the data, and finally save this data. So similarly, in Spark you can create the pipeline, but the advantage here, you don't have to write some part in other like Java, some part in shell script, then you write some code in Spark SQL and some code you write in. So this kind of complicated pipeline you should not create, because Spark SQL provides both the language, both the way to do work using the procedural language as well as SQL queries. So using the procedural language, like you write your code in Java to like what I would say, let's say if you want to format some data, okay, and then formatting like date you want to convert in format to this format, remove some bad records kind of things, you can do in shell script even etc in Java itself, or any code you write it and then you fire the SQL queries on that kind of thing you would create, correct? So in Spark SQL what they are saying, you can write program itself in Spark SQL, plus you can write SQL queries together. So what they are providing, that is what their feature is. They say we are using both API as well as SQL queries. Generally if you are going, let's say assume it you are working on Oracle database, correct? So writing the procedural language means you are going to write the either store procedure, which is I would not recommend like writing a big store procedure to do your work. If database purpose is select, insert, update and delete, procedural you should avoid this. For that work you should give it to the languages, programming languages which are responsible for. So if you have seen like lot of JDBC work kind of thing and you just fire insert, update, delete kind of thing, so if good programmer would never try to write the code in the stored procedures, functions, etc. They would prefer to write in the programming language, because there's a concurrency, there are a lot of features available with the programming language, correct? So similarly here what they are saying it, and in the Oracle SQL they don't provide like you write they support, even Oracle support the Java code in the SQL interface itself, but that is not at optimal as it should be, correct? So but in the Spark SQL world that is a different thing altogether. You use the procedural language as well as SQL queries together in the single module, and you can create entire pipeline in the single module. That is the point here. Actually the point here is, rather than mixing different programming languages, you use either Python, either Scala, either Java, correct? And you can write your procedural language part as well as your SQL queries together to create the entire pipeline and then finally save the data kind of thing. So that is you can do this. Okay, so what is a schema? In inferences, like inferring the schema. Okay, so if I have given you the file, okay, and let's assume it I have given a one comma separated file like this. Okay, just give me a minute. We have been given this file, kind of this CSV file. This has a 4 column. This is the name column, this is the fee column, this is what do you say, date column, let's assume it, and this is the venue column, okay, where the training is, correct. So this is string column, this is integer column, this is date type, and this is the string type, correct. So now schema inference means using the okay, so Spark or should be able to infer the schema from the data itself, or if it cannot, then you can provide the case classes in the Scala or Java beans in the Java to infer the schema from the data. In case of Python what does exactly, it's a dynamic language, correct. If you I'm not sure how much you are familiar with the Scala. Scala is a static, Scala and Java static type of languages, correct, and Python is a dynamic type of language. So there is no as such types available in the Python automatically find it out what is the type of this data. If you provide in the Python, if you write 1 2 3, then Python automatically understand this is an integer value. In Scala also it understand it is an integer value as soon as you write 1 2 3, but the point here is internally it is like, okay, it is it's a written on Java. Scala is written on Java, correct. So and Java is a static type of language. You have to explicitly tell like this is an integer value 1 2 3, otherwise it wants automatically identify this is as an integer value. So similarly in Scala, it's infer the Scala infer the it's the beauty of the Scala framework, like that is they find it out and they put the, so suppose in a Scala you write well I equals to 1 2 3. So actually internally Scala is does it convert into the Java, and it what it does, it would say it is integer I equals to 1 2 3. So still Scala is a has to convert because it has to be run on the JVM, correct. So that's the reason Scala is a static type of language. You have to explicitly define the types. That is what here mean static type means. Okay, so whenever you work with the data, it has to be automatically defined what is the type of the data. So that is the static type. But in case of the Python, if you write 1 2 3, Python is able to understand it's a integer. If you write something Hadoop exam something like that, Python automatically understand this is a string. But in case of Java, that is not the case. You have to explicitly write this is string, this is an integer kind of thing. That is the difference. So, okay, so now Python, how do Python infer the schema from the data? So what, while reading the data, when you provide in a Spark SQL, if you are using the Python language, then it will automatically what it does is bring the some sample data, and then based on the sample data's values it will derive the schema. So it's a data type and it's column names from the header if it is a CSV file, and if it's JSON file, then from the schema it would find it out what is the data type should be each column, correct. In case of Scala and Java, you have to explicitly provide this is the case class and map this. Okay, we'll do the hands-on for this, what is the case class and all this is. Case class is a Scala concept, so if you don't know the case class, then I would recommend go for the Scala training which we also provide, okay. And if you don't know Spark at all together, then also core Spark training is we are providing, go for that, okay. So that is very important. If you should know the core Spark, that is the assumption here, okay, because Spark SQL is a advanced topic of the core Spark, so you should be aware about this, what is the core Spark, okay. Columnar format, okay. So okay, in detail I cannot go again here. What is the columnar format? It's like storage, the way it is the optimal uh, in some scenario it is the optimized way of storing the data. Okay, so suppose let's assume it, very simple example I'll give you. It is very difficult for me to in depth discuss it, but let's assume it, we have a course name here, a fee here, and this is a let's say when this course happened, correct, and assume this table is a huge, let's say huge means 100 million records. Okay, now what happens in the columnar storage, actually if I need to get the sum of this fee column, sum of all these fees, what in regular databases and storage system, it what it does is actually while storing the data, it will bring out this, out of 100 million, let's say 1 million record, it bring it out and store in one partition 1 million record. Okay, one place, another 1 million in another record, another 1 million in another place. So there is 100 such block would be created, correct, for 100 million record. But in this is row storage, you can say, kind of thing. But in case of columnar storage, what it does is actually it will bring this entire column together. It could not be like at one file, but it could be together, all together. Entire name column would remain at one place. Okay, entire fee value would remain in the one place, and entire date column would be in one place. So if I need to get the sum of the fee, so I don't need to read this part, not read to this part, I just read this part is enough. Here you can see how complicated it is. You have to read this and then filter out, remove both the other two columns and then sum it. But here what I do, I read this column, add all the values and give you the sum. So that is the columnar storage. The very simple idea I'm giving. It's too much things are there to do. More explanation can be given, but for basic understanding, you understand like what I'll do. I'll store the entire column together, and if I need to know what is the average fee, so I don't have to read this column, correct, this part, I just read here and go here and get the average value out of this. So that is my average, I would get it, correct. So similarly, if I need to get the max training, that minimum training that date, I won't have to read this column, this column, I just go read here and then fine. So that is column. So Spark SQL by default save intermediate data or final data as a columnar format, and this columnar format is known as a parquet file. Okay, so if you don't know what is parquet file, again we have a Hadoop training, in that we have discussed, because this parquet file format was developed by I think Cloudera, and this is being heavily used with the Hadoop framework. So there is a lot of advantage on the compression side, or there are a lot of things to be discussed. So I'll not go in detail. You have to go to Hadoop training module and you will get to know. So let's take the last topic of this session. Okay, user defined functions. So if you know the Oracle database SQL or MySQL or any other database, correct, so you see you can create your own functions and procedures, correct. Similarly, in Spark SQL, if you want to extend the functionality, Spark provides their own functions as well, correct, like other SQL or engine also provide, like max value, mean value, pivoting the values, group by the values, getting the average, getting the like this kind of functionality is already available, and default functions are available. But in the Spark SQL, the same things also available. But if you still want, some functions are not available and you want your own functionality to be implemented, so you create the SQL functions in the SQL languages, correct. So similarly, you can create the functions here in the Spark framework as well, and these functions you don't have to deploy it separately and compile it separately and kind of thing. That is the beauty of the Spark SQL. You can write function inline of your code, use these functions, finish, that's done. You don't have to create the separate package and kind of thing. If you want these functions to be used in the SQL queries, I will do this hands-on exercise, don't worry about this. Okay, I'm just telling you the concept right now, but we will actually do deep dive hands-on for this things. Okay, and you have to just register this function and use like let me give you example here. If you have select average fee from table, correct? So this is the query. So this is inbuilt function provide average fees, correct, to get the average fee. But if you want some functionality of like total okay, not average, let's say total fee I wanted to get it, correct, and which take two input parameters, fee plus tax rate, whatever is the tax rate, okay, and based on this is final value. So suppose 100 is my fee and 18% is the tax, so final value is 118, correct. So this I want this functions by default is not available. So what I'll do, I create my functions to do this calculation. I'm giving very trivial example here, but you can implement complicated example as well, which we will do in like a little complicated while doing the hands-on session, okay. And you can get the total fee for this by applying this 18% tax, okay. And this kind of functions you can write it, and it would be very easy like if, to work with the functions, user defined function in the Spark SQL. So and UDF can be written using Java, Python, Scala. These three languages you can use it, and again it can be written in the same languages in the same, hence you can debug using the any standard tool as we have mentioned previously, correct. So that's all about in this session. Thanks for watching, and I hope you like this session. If you're watching on YouTube, don't forget to subscribe our module, and we are keep updating our materials and keep adding new materials. So these are the currently available trainings. I'm not sure, you have to visit the hadoopexam.com, and these are the all materials available which we generally put first on the home page, so you can get the entire material on the home page itself what we are providing right now, the certification material, programming languages training, big data trainings, etc. So we are keep adding, and we have recently added books as well in our material. So these are various things which we are providing. I would suggest go and deep dive on this site to get more detail what we are providing. If you still not able to understand, there is a way. You just drop the email to either of this email ID. You can call on this number, or you can use WhatsApp to do the WhatsApp using on this number, okay. And finally you can subscribe here by clicking on the subscribe button, put your name and email ID, so we can provide you any update whatever if we do in future. So thanks for watching, and don't forget to subscribe, and don't forget to refer your friend. Thank you.